matrix A equal to 1, 1, 1, 1, 2, negative 3, 2, negative 1, 3, a matrix of order 3 by 3. We have to prove that A cube minus 6A square plus 5A plus 11 times the identity matrix equal to 0 matrix. So let us work out A cube minus 6A square plus 5A and plus 11I separately, and then we will substitute in this relation 1 on the left hand side. So let us first of all work out A square and hence A cube. Given in the matrix A as 1, 1, 1, 1, 2, negative 3, 2, negative 1, 3. So what will be the value of A square? A multiplied by itself, that is 1, 1, 1, 1, 2, negative 3, 2, negative 1, 3 multiplied by itself, that is 1, 1, 1, 1, 2, negative 3, 2, negative 1, 3. Now both the matrices are of the order 3 by 3. So the resultant matrix will also be of the order 3 by 3. You know very well how to multiply the matrices that start multiplying with the first row of the first matrix to the first column. Multiply respectively, you get 1 plus 1 plus 2. Then repeat the process with the second column, you get 1 plus 2 and plus negative 1. 1 plus 2 plus, that is minus 1. And then to the third column, you get 1, negative 3 and plus 3. 1, negative 3 and plus 3. Now repeat the process with the second row. With the second row, multiply the first column, second column, third column. We get 1 plus 2 plus negative 6. 1 plus 2 plus negative 6. Multiplying to the second column, you get 1 plus 4 and plus 3. Multiplying to the third column, you get 1 and minus 6 and minus 9. And now repeat the process with the elements of third row to the first column, second column, third column. So you get 2 minus 1, 2 minus 1 plus 6, 2 minus 2 minus 3, and you get 2 plus 3 plus 9. Just work it out and you get A square equal to 4, 2, 1, negative 3, 8, negative 14, 7, negative 3, 14. So we have worked out A square. And now to find out A cube. What is A cube? A cube will be obtained by multiplying A with A square. So multiplying A and A square, substituting the value of A 1, 1, 1, 1, 2, negative 3 and 2, negative 1, 3. We have already worked out A square is 4, 2, 1. The elements of the second row are negative 3, 8, negative 14 and 7, negative 3, 14. Take the product. Both these matrices are of the order 3 by 3, so will be the product. So multiplying the elements of first row with the first column, you get A cube equal to, this will be of the order 3 by 3. So multiplying the element of first row 1, 1, 1 with first column, you get 4, negative 3 plus 7. Then with the second column, you get 2 plus 8 and minus 3. And with the third column, you get 1, minus 14 and plus 14. And similarly, I leave for you to try that you take the product of second row with column 1, 2, 3 and that of the third row with column 1, 2, 3. That by now you can try yourself. So finally, if you work it out, the value of A cube will be 871 minus 23, 27 minus 69 and 32 minus 13 and 58. a matrix of order 3 by 3. So now let us work out the required result. The left hand side of the required result is a cube, which we have worked out, minus 6 times a square we have worked out, and this 5a and 11i we can work out here only. So now substituting the values, the value of a cube is 871 minus 23, 27 minus 69 and 32 minus 13, 58. And then minus 6 times a. What is the value of a? 421, negative 3, 8, negative 14, 7, negative 3, 14. And then 5 times a, the given matrix, 1, 1, 1, 1, 2, negative 3, and 2, minus 1, 3. And what else? Plus 11 times the identity matrix, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. So you get, keeping a cube for time being as such, you just rewrite a cube and multiplying by negative 6, you get negative 6a equal to negative 24, negative 12, negative 6, and then with the second row you get 18 minus 48 plus 84, and you get minus 42 in the third row, 18 and minus 84. And likewise 5a, multiplying each element by 5, you get 5, 5, 5, 5, 10 minus 15, and 10 minus 5, 15. And plus, multiplying by 11, you get 11, 0, 0, 0, 11, 0, 0, 0, 11. And now add all these elements. Add the elements of, the corresponding elements of all the matrices. So you get 8 minus 8 plus 5, 13, plus 11, 24 minus 24. You can show the details, and rest of the two will be 0 each. Then you will get 0, 48 minus 48, and 0, and you get 0, 0, 84 minus 84. So finally, you get 0, 0, 0, 0, 0, 0, all the elements equal to, that is a 0 matrix. So we conclude that by now we have established the required result, that is a cube minus 6a square plus 5a plus 11i equal to 0. So this is the required result. But now further he says, using this, remember, using this result, find A inverse. Sometimes the students feel that okay, if not this way, I can find independently A inverse as 1 upon determinant A into adjoint A. I'm sorry, you will not get any marks. It is using this result, you have to find A inverse. See how you do that. Multiplying each element on both the sides by A inverse. Let us say post multiply, that is multiply on the right side of each term. Post multiply each element by A inverse. So you get A cube into A inverse minus 6A square into A inverse plus 5A into A inverse plus 11I into A inverse equal to 0 into A inverse will remain 0. And now here we'll make use of certain results, that A into A inverse or will be I, identity matrix multiplied by A will make it A, etc. These simple results. So the first term may be written as A square into A, and A into A inverse we can combine in one bracket. Similarly, the second term A square may be written as A into A, and A into A inverse I'll combine. In the third term, it is 5 times A into A inverse. I can now write identity matrix. And identity with A inverse in the last term will keep it 11 times A inverse equal to 0. And now A square as such, A into A inverse is identity. minus 6a as such, again A into A inverse identity, plus 5i plus 11 times A inverse equal to 0. Let me take one more step. You know, A square into I will, after all, A square is also a matrix multiplied by identity matrix will keep it A square. Similarly here, A into I will keep it A only. So A square minus 6A plus 5I and plus 11A inverse equal to 0. And from here, what is the value of A inverse? Okay, at least 11A inverse. Take all the other terms on the right side. You get on the right side minus A square plus 6A and minus 5I. So replacing the values, you get 11A inverse equal to negative times. You know the value of A square we have worked out as 421. Just check up from there. A square is 421, negative 3, 8, negative 14, 7, minus 3, 14. Similarly, 6 times the value of given matrix, that is 1, 1, 1, value of A, 1, 2, negative 3, and 2, minus 1, 3. And of course, you know the identity matrix of the third order is 1, 0, 0, 0, 1, 0, and 0, 1, 0, and 0, 0, 1. Now work it out. In the first term, you just make a change of sign in all the elements to get negative 4, negative 2, negative 1, 3, negative 8, 14, minus 7, 3, minus 14. Multiplying, if for the second term, multiply each element by 6, you get 6, 6, 6, and then you get 6, 12, minus 18. In the third row, you get 12, negative 6, 18. And the last term, you multiply by negative 5 inside, so you get negative 5, 0, 0, 0, negative 5, 0, 0, 0, negative 5. Now all the three matrices being of the order, 3 by 3, just add the corresponding elements, and on the left side you have 11 times A inverse. So what will be the value of A inverse? Dividing by 11, 1 by 11 times, 1 by 11 times, add the corresponding elements. So if you add the corresponding elements, you get the value of A inverse finally, 1 by 11 times, add the corresponding elements, you get say negative 4 plus 6, negative 5. So it is negative 9 plus 6, that is negative 3. Similarly, it is 6 minus 2, that is 4. So rest of them you can work out yourself, and you will find that the elements of the second row are 9, minus 1, negative 4, and 5, negative 3, negative 1. So this is the value of required result, required value of A inverse using the given result. 1 by 11 equal to negative 3, 4, 5, 9 minus 1 minus 4, 5, negative 3, negative 1. Yes.